Okay, so I hope you are already working on your bridge projects and you had made your groups. So from this class and onwards, we are going to model the reinforced concrete girder bridge. Okay, so let's define our problem. So what sort of bridge exactly we want to model? Well, it could be a reinforced concrete girder bridge and I give you choice whether you want this bridge to be the T girder bridge, or you want the girder as an isolated beam and the slab is resting over the girder without any monolithic connection but with the help of shear connectors. So we'll proceed for that, but before that let's decide the general information of your bridge. And this time I want your bridge to be a continuous bridge. I want to have the bends. You know, the bends, the assembly of columns and the beams or cap beam is together known as bend. So let's design a continuous bridge. Before in our class we did a simply spotted bridge, but I want to have a continuous bridge in this problem because it is more complex and it has bends. Because in the previous example we just had the abutments. There were no intermediate supports. Okay. I can tell you how you can make the girders the isolated one. So what about the total width of the bridge? How much you want the total width of the bridge? You want it to be the 2-lane, 3-lane, 4-lane, or what?
4 lane.
4 lanes. So 4 lane. 4 lanes. So let's decide the layout of the bridge. 3.6 is the lane width multiplied by 4 plus. Now you want the overhang on the curve. Let's take, so the median width, let's take 380, the median 0.38 is the median,
Multiply by 3.
and there are 2 curves. Do you want footpath or not?
Not but maybe just 30 centimeter.
Curve is there, so 0.38 is a curve. So how much will be this total? Okay, let's do it in millimeters. So this 1,380 is for the curve so the 1,380 is for the median and 2,380s are for the curves.
15,160. 15,000.
So 15,540. Okay, so in this case, let's take the overhang like 1,000 as it is. Barrier, I already considered the barrier is 380 here, and it is a 4-lane bridge. There are no footpaths. Concrete strength in this case, let's take 35 megapascal. And steel strength, let's take 60 grade for, and if you want to add more steel, like steel for stirrups, like how much? 40 grade. 40 grade mean 300 megapascal. Asphalt thickness, okay, the effective span, yeah. Now we have to decide the length of the bridge. The total length of the bridge, how much? Tell me. There will be 2 bends, there will be 2 supports. So how much should be the total length of your bridge?
12.
12?
No,
No,
think
20,
It's a girder bridge.
20 and then above.
20, 30.
15, 15, two spans only? You want two spans?
Let's make it 3.
Let's take 30 meter. It is my opinion.
Every span is a bit.
And
Every band,
3 span,
two
2 span.
2 band,
bends
and every region.
each at 10 meter interval. Okay? So the effective span you can say is like 10,000 millimeters, and the H minimum, the minimum slab thickness, you can calculate it here from this formula, which is from the ASTO. S is the spacing of the girder, which we have not decided yet, but we can do that. Okay, so this is a bridge problem which we have to model in our class. Okay, let's start it. So I will be very quickly moving through the modeling because I have explained you each and every step in a lot of detail. So, but still, it is not an easy task. New model. I would like to start it from the blank or from the scratch. I mean, there is nothing, and we will model each and everything for the bridge. The first step, we have to set the units. Which units we should?
Kilonewton millimeter.
Okay, if you are more comfortable with the kilonewton meter or millimeter.
Millimeter.
Okay, kilonewton millimeter.
For that, you'll need to unlock your phone.
Okay. So this is a blank, and now let's go for the bridge. The first step, we have to decide the layout line. I explained you the layout line means the center line of your bridge. Okay, so add new center line of your bridge. Well, this is the initial station, and here it is already 30,000. Great. So it is already 30,000 here. So this is the initial station and this is the end station. So the total length of your bridge is 30 meter. And I already explained to you, if you want to add a curvature or if you want to add a vertical curve, if you want to have the bridge on grade, we can include all these things. But I want to model this bridge as a flat bridge. In our next problem, problem of the bridge, I would like to model a pre-stressed bridge which will have changing cross section. Do you understand? In that bridge we will be having a pre-stress bridge, and the section or the depth of the girder will also vary. I'll show you how we can do that, but that is the end. After that you would be able to model any kind of bridge. Okay. So let's go for that. Any change in this you want? Okay. Next, deck sections. Add new section here. This is the deck section. Now, we have so many choices. Like these girders are the concrete box girder, and these are the other concrete girders which still exist, and still many of the bridges, the medium and low span bridges, are constructed using these type of girders. For example, the flat slab bridge we have already done in our previous class. So today either we will go for the T-beam bridge or precast I girder bridge. What is the precast? Precast, we cast the bridge at some other site and we transport the girders at the bridge site and we connect with the help of shear connectors. Or we can place the slab later on with the help of formwork. So it is a difference. Precast means the bridge or the girders are already casted. Casted means prepared, cured, and now they are ready to move. Okay, and this one, it means they are the monolithic. Monolithic, they have no joints in between them. it is the like all the beam and slab, they will be cast at the same place on the site. So which option you would like to proceed? Precast. Okay. Precast bridge girders. Okay, so in case of precast bridge girders, well, in our class we did the monolithic one, but it's not a big deal. So in that case, we have now two types of section. The one section you can see here, they are right in front of you, and the other section are the rectangular section. Now my next question is that, would you like to change these I-beams to the rectangular one, or you want to keep them as it is?
For this situation, it's more difficult.
Well, this is the bridge section. We can say bridge, our bridge section name, like Girder bridge, RC, G bridge. This is reinforced concrete Girder bridge. The slab material property, we can add the material here. For example, we can go to the materials. We can add new concrete material or the copy of this material. And here I say concrete 35. Let's change the units Newton millimeter because we are more familiar with the megapascal. So here it is a model of elasticity, Poisson's ratio, thermal expansion, and here I will give the concrete strength 35,000, sorry 35 megapascal. And I should change this to, like according to the ACI, it should be equal to 4700 under root FC prime. So how much is this? 235. Oh, it's 30. Should be 35. So it is 27805. I should use this value. The other things I can keep as it is. Okay. So this concrete 35 is there. Now I can choose this material here. The number of girders. Now we have to decide the number of girders. Now the total width of your bridge is 15 meter. Okay. And 1 meter is the overhang. So now let's decide the number of girders. The total width of your bridge is 15,540, this one.
Yes.
So how much overhang you want? 1000 on each side. Minus 2 times, how many girders now? 5. Let's subtract 5 into S. The spacing between the girder. So how much will be the S?
3,600.
Check. How much will be the S?
Just wait. 2,708. So I think it's a little bit more wide. I would prefer to be on 2.5. So what if we have 6 girders? Calculator. 2,256.
2,000.
257 or 56.7. 56.7.
So what I do, I keep my girder spacing at 2,250. And the remaining one, I put on the overhangs. So there are how many girders?
6,
7.
7.
7 girders now. These are the 6 spacings. And the number of girders are more than that. Okay, so now you are going to have 7 girders. 7 girders. Okay? And each girder spacing is 2250. 7 girders 6 into S plus 2 into overhang is equal to 15,540. So now you can have your overhang. How much will be your overhang? This is, I'm deciding the layout of the bridge.
1,005.
How much?
1,005.
Just 1,005. Great. Okay. So now you see, I reached to the same, almost the same solution which I have decided before, the overhang around 1,000. Do you remember? Okay. So this is how I did. Let's move next now. So how many number of interior girders?
To be 5.
5. Okay. The total weight is how much?
15.
Okay. And the girder are along the length. Now you see the number of girders are increased here. See on this side. Okay.
I think the number is wrong in word. Go to the word part.
100.
It's not 1,005. 1,020.
This one?
Yes.
I'm not sure.
20.
Whatever. Okay. So girder longitudinal, yeah, they are along the layout line, the straight line. Now, because here we have two choices. Along our layout line is perfectly straight, but if it is not straight, then if it is in a curvature, then we can choose which option we want. Either we want our girders to be the straight line or along the curve. We can do that. Constant girder spacing, yes. You want to increase the depth of slab above girder, or you want to keep the same? Do you understand? Above the girder here, if you see, there is a slight increase in the depth of slab.
Yes.
Would you like to increase this depth, or you want to keep it same?
What's the benefit?
Small.
The benefit is that in that case, for example, it provides the good seating, number one. For example, and if you have the shear connectors, like the dowels going out of the bridge, you can find more space for the dowels. So this could be the benefit. So, but the punching shear is no more existent over there. So if, for example, if there is a wheel load, it can cause a punching failure of the bridge, punching of the slab. So in that case, it can provide more resistance. But not always, because it is the same. So tell me. Okay, if you want, you say yes, it will be, but if you say no, it will be now constant. Okay? And if you say yes, now you can have the, okay, let's move with the yes. So now the slab thickness here, the slab thickness at the center, T1, the slab thickness of the bridge, of the deck. So we have this formula and we have calculated somewhere here. Please check. How much is S now? S is now 2250. So put S in this formula and find out the thickness of slab. 175 mm. Give some margin for the concrete and make it 200. Okay?
Victor, I think this is more simple as well. So, continuous.
I already changed it for the continuous one. 200, let's say 200. And concrete haunch thickness, for example, this haunch, this increase in depth, you can make it,
Yeah.
if you want increase in depth, you can keep as it is or like 100, but if you want to make it 0, there will be no haunch. Now you see on this side, see, don't see here, see here, so it is changed now. Before it was, for example, if you give 100, you can see the haunch here. Can you see? If I make it 0, it's gone. So it's your choice. Let's give small haunch, 50 mm only. Okay, girder section. Now, you can have, for example, what is this F section 1? The program has already given F section 1. For example, what is this girder section? Go here and modify and show property. If you click, you can see this is your girder section, F section 1. And here you can see some of the default ASTRO girders. There are like type 1. What is the depth of this girder? The total depth? 700 mm. For example, this is D1, total depth, and this is 700. If you want to make this girder rectangular, how you can do that? I tell you. For example, let's say we have two types of girder. You want this to be exterior or interior? Or same? Girder. Now, I convert this girder into your glass bridge problem. I remember the total width of your girder was how much? 450, 50, oh sorry. So it has become rectangle. Now the depth, just you have to change the total depth, everything will be adjusted accordingly. The total depth of your bridge girder was 1250. So this is your bridge girder actually, 450 and 1250. There is no need to adjust, even if you make them 0, it is not going to make any effect.
Yes, section shows which side of the
This is rectangular girder. This is the width and this is the depth. So 1 is along the length, 2 is the gravity and 3 is the moment, M3 and V2. Okay? So there is no need to, even if you adjust these values, there is it will not make any difference. For example, if you make 300 or if you make 400, you cannot put it 0, but it will not make any difference. Because all these changes will be within the rectangle. Because this is D2, it will increase or decrease. It's not going to make any change. And the material you can make concrete certified. This is how you can change this girder to your own girder specs. And if you make it okay, now here it got stuck. So let's see how long we have done. First, let me save my model. This is the same mistake which most of the people do during the modeling. and even some students they do in the exam. I mean, in the graphics exam, they don't save their files; they keep on working. Okay, it got stuck again due to some reason, but this is how we can adjust the girder specification, and we can adjust our bridge dimensions. I wish that it has not this file has not damaged, otherwise I have to repeat all these things again. I think you're not that lucky, so I have to regenerate the model from scratch. Let's see. Because it's not working. Okay, and in this case, in this model, do you want to consider the HL93 truck or the same HS20 which we have included? For example, again, in this model I give you two choices. Number one, apply the truck load separate, lane load separate, or define like as an HL93 truck and train lane together. Which way would you prefer? HL93, the easiest one. Okay, no problem. I'm struggling with my model. Sorry. Okay. So what should I do now?
Just one. That.
Okay.
I do that.
I really don't want to stop this one. Maybe it get videos. Okay, let's do it very quickly. Yes. Next stop. This is RC. Okay, I open the bridge model again. Let's see, is it saved or not? Open the file, open from here, and then go to bridge text sections. Oh, it is not there. But what about the left line? Is it there, the left line? Yes, it is there. So we have to change the text sections, add new section here. And this one we were working. This section is the RCG bridge. Material is there or gone?